Hello students, today we shall discuss next topic of electricity. Name of the topic is resistance of a system of resistors. At first, we know that resistors can be connected in different ways. So first point is resistors can be connected in two ways. Number one, resistors in series, and number two, resistors in parallel. We shall discuss these one by one. At first, we shall discuss resistors in series. Resistors in series. First point, definition. Two resistors are said to be in series when they are connected end to end. Two or more resistors are said to be connected in series when they are joined or connected end to end. End to ends mean let this is first resistor and it will be connected with the second resistor. This is second resistor. So they are connected end to end. First resistor with its end, second resistor and third resistors. These resistors are connected end to end. Now, law of combination of resistors in series. Law of combination of resistors in series. It means if resistors are connected in series, then how shall we calculate its total resistance? When resistors are connected in series, then total resistance is equal to sum of resistance of individual resistors. If we connect them in series, then we add the value of their resistance and we will get total resistance. For example, again, let it is first resistor of 5 ohm it is connected with second resistor of 7 ohm and which is connected with third resistor of 8 ohm. It is R1 resistor number 1, R2 and R3. Then R, which is total resistor. R is equal to R1 plus R2 plus R3. Total resistance is equal to sum of individual resistances. If there are 3 resistors, then R1 plus R2 plus R3. If there are 2 resistors, then R is equal to R1 plus R2 and so on. So R is equal to value of R1 is 5 ohm plus value of R2 is 7 ohm plus value of R3 is 8 ohm. So thus R is equal to 5 and 7 12 and 8 20 ohm. So thus we have studied that resistors can be connected in two ways, in series and in parallel. Two or more resistors are said to be connected in series when they are joined end to end. This is diagram. 3 resistors are joined end to end. And to calculate the total resistance, we will simply add. Now next. Next, characters of resistor or resistance in series. Characters of resistors or resistance in series. When resistors are connected in series, then there is only one path for the flow of current. Therefore, same current passes through all resistors and also through the whole circuit. So this is first law. First law is when resistors are connected in series, then same current passes through each resistor and through whole circuit. This is first law. Same current through every resistor as well as through the whole circuit. But potential difference is different, which depend upon the value of the resistance. Each resistor have different potential difference, but total potential difference which is also known as voltage equal to sum of potential difference of individual resistance. So thus its mean every potential difference, every resistor has different potential difference, and this value of potential difference depend upon value of resistance. But sum of the potential difference of whole circuit is equal to the potential difference of individual resistance. That is, V is equal to V1 plus V2 plus V3 and so on. These are the two main characters or characteristics. But sometime in exam, if more than two are asked, then you can also write R is equal to R1 plus R2 plus R3. You have to remember that while writing the characters, we will write these two, not the third one. But if required, means it is asked in question that write the three characters, then you can write sum of the resistance of the whole circuit is equal to the sum of the resistance of the individual resistance. So these are the three characters. Now we shall study how to draw the formula of it. Derive formula for equivalent resistance when two or more resistors are connected in series, or derive formula R is equal to R1 plus R2 plus R3 for resistance in series. Solution. So it is that we have to derive formula for equivalent resistance when two resistors or three resistors or four resistors or more resistors are connected in series. So for that, at first we shall draw the diagram. 1, 2, these are three resistors. It is positive end of battery, it is negative end of battery. We know that current flow from negative end to positive end, but in diagram we show conventional direction, that is from positive end to negative end. Now these resistors are connected in series, so we shall perform the following equation. Here we shall connect voltmeter V1, V2, V3, now three resistors having resistance R1, R2, R3 respectively and potential difference V1, V2, V3 respectively are connected in series. Let potential difference of the whole circuit, that is battery, is V and resistance of the whole circuit is R. So we shall write, let three resistors of resistance R1, R2, R3 respectively are connected in series. Having potential difference V1, V2 and V3 respectively. Let R is equivalent resistance and V is potential difference of whole circuit. Now we know V is equal to IR. It is by Ohm's law, number one. And we also know V is equal to V1 plus V2 plus V3. It is number two. And V1 is equal to I R1. V2 is equal to I R2. V3 is equal to I R3. It is number 3. By Ohm's law, V is equal to IR. We know that sum of the potential difference of the whole circuit is equal to sum of the potential difference of individual resistors, and V1 is equal to IR1, V2 is equal to IR2 and V3 is equal to IR3. So by 1, 2 and 3 we will have this IR which is equal to V, but V is equal to V1, V2, V3 and value of V1 is IR1 plus IR2 plus IR3, or I is common here, R1 plus R2 plus R3. We shall cancel this I. R is equal to R1 plus R2 plus R3. Thus, we derive the formula for equivalent resistance when three resistors are connected in series. If in question it is asked two resistors are connected, then you will not write or show R3. So it is everything about the resistors in series. So I have told you that resistors can be connected either in series or in parallel. In series, when they are connected end to end, and in series same current flows but potential difference is different, and R is equal to R1 plus R2 plus R3, and we derive its form. Now we shall study resistors or resistance in parallel. resistors in parallel. Two or more resistors are said to be connected in parallel when they are connected between two fixed points. Two or more resistors are said to be connected in parallel when they are connected between two points. Let these are 2 points. Now this resistor is connected between these 2 points. Similarly, this resistor also connected between these points, and this resistor is also connected between these. Thus, 3 resistors R1, R2 and R3 are connected between two fixed points. Therefore, these are termed as resistors in parallel. Now, C is law of equivalent resistance for resistors in parallel. Law of equivalent resistance for resistors in parallel. When resistors are connected in parallel, then how shall we connect total or combined or equivalent resistance or resistor? The law is that reciprocal of equivalent resistance is equal to sum of reciprocal of individual resistances. If R is the total resistance, that is the resistance of the whole circuit, then reciprocal means 1 by R. It is reciprocal of R, that is reciprocal of equivalent resistance, is equal to sum of reciprocal of individual resistance, and so on. So 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. We can also explain it by an example. Example. Let these are two fixed points and between them three resistors R1, R2, R3 of, you can say, like 5 ohm and 10 ohm and 20 ohm are connected in parallel. Then how shall we find equivalent resistance? So R1 is equal to 5 ohm, it is given. R2 is equal to 10 ohm. R3 is 20 ohm. R, that is equivalent resistance, we have to find. So here we can write here 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. That is 1 by 5 ohm plus 1 by 10 ohm plus 1 by 20 ohm. Their LCM is 20. 4 plus 2 plus 1, that is 7 by 20 ohm. Do not forget to write R. It is value of 1 by R, not of R. R is equal to 20 by 7 ohm. Divide and you will get the value. 7 2s are 14. Ohm approximately. So this is how we calculate equivalent of total resistance in parallel. Now next point is characters of when resistance are connected in parallel. Characters when resistors are connected in parallel. So there are again 2 or 3 characters. In series same current flows, but in parallel different amount of current flows. Different amount of current flows through different resistors, but sum of current drawn by circuit from source is equal to sum of current drawn by individual resistors. That is I is equal to I1 plus I2 plus I3, where I is the current of the whole circuit or current drawn by the whole circuit. I1, I2, I3, I4, etc. are the current of the individual resistance. And second point is same potential difference through the ends of the each resistor. potential difference, which is also known as voltage, across end of each resistor as well as across whole circuit is same. So these are two laws. Different amount of current flows and potential difference is same. If three laws are asked, then you can write 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So thus here we studied that two or more resistors are said to be connected in parallel when they are connected between two ends, and total resistance, reciprocal of total resistance is equal to the sum of the reciprocal of individual resistance, and these are the characters. Different amount of current flows through different resistors, but potential difference of the battery of the whole circuit as well as of the individual circuits is same. Now, how to derive the formula for the equivalent resistance when resistors are connected in parallel, that we shall study in next class. Thank you.